The industry sold us a myth. They told us that embeddings were the silver bullet for enterprise intelligence. You built the vector database, you ingested the documents, you spent the budget, and yet, the hallucinations haven't stopped. In reality, mathematical similarity is not the same thing as business relevance. We fell into the top K trap. This is the moment where your Copilot retrieves the most similar data point in the high-dimensional space. But that data happens to be 100% wrong for the specific task at hand, because in 2026, proximity is a cheap proxy for truth. If your RAG project is currently stalling in the pilot phase, it's not because the AI is dumb. It's because your retrieval strategy is built on an illusion. The structural failure of pure vector models. Vector search is a commodity layer. In the architecture of a modern AI system, it's the basement of the stack, not the penthouse. But we've been treating it like the brain. The fundamental flaw in high-dimensional embeddings is that they are fuzzy by design. They represent concepts as coordinates. That works beautifully when you're looking for vibes or general topics. But work doesn't happen in the land of vibes. Work happens in the land of specifics. And this is where the pure vector model breaks. Vectors struggle with exact terms. Think about product codes, SKUs, legal terminology, internal project code names. To a vector model, Project Phoenix and Project Firebird might look mathematically identical because they share a semantic cluster. But to your finance team, they represent two entirely different budgets. When you rely solely on dense embeddings, you are essentially asking the AI to guess based on a neighborhood. The result? A 27% error rate in business outputs. That's not just a technical metric. That error rate translates to 1.8 hours of employee time wasted every single week. People aren't using Copilot to work faster. They're using it to generate drafts that they then have to spend 2 hours fact-checking because the retrieval set was noisy. We have an accuracy crisis, and it's not an LLM problem. You can't fix this by switching from GPT-4 to GPT-5 or moving to a larger context window. It's a retrieval engineering problem. We made a massive assumption. We assumed the math would handle the context. We thought if we just turned every document into a list of numbers, the relationships would emerge. But context is structural. It's not just probabilistic. In an enterprise environment, the meaning of a document isn't just in the words. It's in the metadata, it's in the permissions, it's in the specific versioning that a vector model completely ignores. When you search for the latest travel policy, a vector search finds the policy that sounds most like a travel policy. It doesn't necessarily find the one that was approved yesterday. It finds the most similar one. And if the most similar one is the 2022 version because it has more descriptive text, that's what your LLM gets, then the AI tells your employee they can book business class, even though the new policy says economy only. That's a hallucination caused by bad data grounding. The model didn't lie, it just summarized the wrong pile of numbers. This is what happens when you use a model designed for discovery and try to use it for precision. Vector search is excellent at finding the needle in the haystack if you don't care which needle you get. But in the enterprise, there is only one correct needle. The other 9 are liabilities. We've reached the limit of what pure similarity can do for us. If we want to hit that 0.9 precision threshold that regulated industries require, we have to stop treating retrieval like a math problem and start treating it like an editorial problem. We need to move past the idea that close enough is acceptable for a system that is supposed to drive executive decision-making. Because right now, the top K results you're feeding your Copilot are just a collection of mathematically related noise. You're asking a reasoning engine to build a house on a foundation of sand. And then we wonder why the roof is leaking. The shift from 2025 to 2026 is the realization that embeddings are just the starting point. They are the maybe pile. To get to the yes pile, we need a different kind of logic. We need to reintroduce the very things we thought embeddings would replace. We need structure, we need lexical anchors. And most importantly, we need a supervisor who knows the difference between a similar answer and a correct one. Without that, your RAG project isn't an intelligence tool. It's just a very expensive, very fast way to be wrong. But here is where the model breaks, because similarity is a cheap proxy for truth. The mathematical neighborhood is a dangerous place to live. We've relied on these dense clusters for too long, assuming that if two things are near each other in a vector space, they must be related in a business sense. But they aren't. Similarity is just a reflection of word usage patterns. It is a cheap proxy for truth, and in 2026 the model breaks because we've stopped looking for related things and started needing verified things. When you move from a pilot to a production environment, the stakes change. The proxy is no longer enough. You need something that anchors the AI back into the actual language of your organization. You need the precision that we accidentally threw away when we went all in on embeddings. The hybrid standard, why BM25 still matters. If you look at the production baseline for 2026, the landscape has shifted. We aren't talking about experimental vector stores anymore. We're talking about the hybrid standard. The data is clear. 72% of successful enterprise RAG systems have moved away from pure vector retrieval. They've implemented a dual-path system that combines the meaning of vectors with the precision of keyword matching. Specifically, they've brought back the BM25 algorithm. For those who haven't spent 20 years in search engineering, BM25 is the classic sparse retrieval method. It's the logic that looks for exact word overlaps. It's the old way that we thought embeddings would kill. But it turns out the old way is the only thing that keeps the new way honest. When you combine these two, something interesting happens. You get a 17% recall gain across your entire dataset. That 17% is the difference between an employee finding the answer in 10 seconds or giving up after 3 failed prompts. Think about what happens when you stop ignoring the specific words your users actually type. In a pure vector system, if a user types Form 10K 2025, the model might prioritize a general article about financial reporting because the vibe is similar. But with BN25 in the mix, the system sees that specific 10K and 2025 string. It recognizes that these aren't just concepts, they are lexical anchors. Hybrid retrieval allows the system to say, I know you're interested in financial reports, but I also see you specifically asked for this exact document. It solves the out-of-domain query problem. This is the biggest hurdle for any pre-trained embedding model. Your vector model was likely trained on a general corpus of internet text. It knows what a contract is, but it doesn't know the specific jargon of your industry. It doesn't understand the proprietary acronyms used in your engineering department. It hasn't seen the internal shorthand your logistics team uses to describe shipping delays. To a general embedding model, those words are noise. They are out of domain. But to BM25, those words are signals. By running a keyword search alongside the vector search, you create a safety net. You ensure that if a user types a specific term that the embedding model doesn't understand, the system can still find the document based on the literal text. This is how you reach the 0.8 precision threshold. In 2025, we were happy if the AI was mostly right. In 2026, 80% accuracy is the bare minimum for entry. Hybrid is the first step toward that goal. It's about anchoring the AI in reality. Think of it as a dual check system. The vector path handles the intent. The what are they trying to do? The keyword path handles the facts. The what did they actually say? When both paths agree on a document, you have a high-confidence candidate. When they disagree, you have a signal that you need more processing. But even with this hybrid approach, we still have a problem. You've improved the maybe pile. You've gone from 78% recall to 91% recall. You're finding more of the right things, but you're still handing the LLM a pile of candidates. And if you've ever looked at a retrieval set, you know that the top 10 results are often a mess. You might have the perfect answer at position 4. But at position 1, you have a document that just happens to have the keyword repeated 20 times. Or you have a document that is mathematically similar but completely irrelevant to the current year. Hybrid search gives you the pieces of the puzzle. It doesn't necessarily put the puzzle together. We assume that if we gave the LLM the top 5 results, it would be smart enough to pick the right one. But LLMs are susceptible to distractor documents. If the first result is a very long, very confident-sounding document that is actually wrong, the LLM will often prioritize that information over the correct, shorter document at position 3. This is the lost-in-the-middle phenomenon. The order of the information determines the quality of the answer. So, while hybrid search is the baseline, it is not the final answer, it's the filtration system. It gets you from 1,000,000 documents down to 50. But 50 documents is still too much noise for a high-stakes business decision. You are still just looking at a pile of candidates. You've moved the needle, but you haven't closed the gap. To actually achieve the 0.9 precision that healthcare and finance require, you can't just stop at retrieval. You need to add a layer of reasoning before the data ever touches the LLM. You need a supervisor who can look at those 50 candidates and rank them based on actual logic, not just frequency or coordinates. Because right now, even with hybrid search, your Copilot is still guessing. It's just making a much more informed guess than it was before. We've solved the finding problem. Now we have to solve the ranking problem. And that requires a completely different architectural layer. Even with hybrid search, you're still just looking at a pile of candidates. You need a supervisor. The problem with the hybrid model is that it lacks an opinion. It generates a list based on 2 different scoring systems that don't really speak the same language. You're merging coordinates from a vector space with frequency scores from a keyword index. The result is a combined top 50 list that is technically better than before. But it's still fundamentally unvetted. It's like a recruitment agency sending you 50 resumes without actually reading them. They've filtered for keywords and general experience, but they haven't verified if the person can actually do the job. In the RAG pipeline, the LLM is your hiring manager. If you hand that manager 50 resumes, they're going to get overwhelmed. They'll glance at the first 3, get distracted by a well-formatted lie, and make a bad hire. To fix this, we need to stop treating search as a one-step process. We need to introduce a secondary layer that acts as a gatekeeper. Because right now, you aren't providing an answer, you're providing a homework assignment. And your AI isn't built to do homework, it's built to reason. If you want it to reason correctly, you need to give it the right starting point. You need a supervisor who can look at the top 50 candidates and decide which one actually holds the truth. Semantic ranking, the final filter for truth. This is where we introduce the L2 re-ranker. In the 2026 architecture, this is the non-negotiable secondary layer. It acts as the editor for your search results. Think about the workflow we've built so far. First, the hybrid search retrieves a broad set of candidates. It's fast, it's efficient, it scans millions of documents in milliseconds, but it's also shallow. The L2 re-ranker is the opposite. It doesn't look at millions of documents. It only looks at the top 50. But it looks at them with a level of depth that the initial search layer could never achieve. Specifically, in the Microsoft ecosystem, we're talking about Bing-derived models. These are cross-attention transformers. Unlike the initial vector search, which compares a query to a pre-computed document embedding, the re-ranker looks at the query and the document together. At the same time, it performs a deep semantic comparison of the actual text. It isn't just looking at coordinates in a high-dimensional space anymore. It is performing deep reasoning to understand if the document actually contains the answer to the specific question asked. This is where we see the @search re-ranker score come into play. This score is different from the similarity scores you see in the first layer. A similarity score tells you this document is mathematically close. The re-ranker score tells you this document is relevant to the user's intent. It moves the goalpost from "is this close" to "does this answer the question?" This distinction is the only way to survive in regulated industries. If you're in finance, healthcare, or legal, 0.8 precision is a failure. You need 0.9 or higher. You cannot reach that level of accuracy with a single-stage retrieval process. The re-ranker is what allows you to move the needle from mostly right to enterprise grade. It solves the most common failure mode in RAG, the wrong order problem. In a standard search, the perfect answer might be sitting at position 8, but because it didn't have the right keyword density or the embedding was slightly fuzzy, it didn't make it to the top. The LLM, being lazy, focuses on the first 3 results. It misses the truth at position 8 and generates a hallucination based on the noise at position 1. The re-ranker stops this. It takes that perfect answer at position 8 and promotes it to position 1. It identifies that while document 1 has more keywords, document 8 has the actual semantic substance required to satisfy the query. This shift from retrieval to ranking is the most important architectural change you can make this year. We have to stop obsessing over how much information we can find. We need to start obsessing over the order in which that information is presented, because the order of information is more important than the amount of information. If the right answer is at the bottom of the pile, it might as well not exist. The re-ranker ensures the truth is always at the top. But this isn't just about moving documents around. The L2 layer also provides semantic captions and highlights. It identifies the specific verbatim sentences within the document that are most relevant. This gives the LLM a cheat sheet. Instead of asking the model to read a 10-page PDF and find the needle, the re-ranker points directly to the needle and says, "Read these 3 sentences specifically." This reduces the cognitive load on the LLM. It minimizes the risk of the model getting distracted by irrelevant context elsewhere in the document. It's the difference between giving someone a book and giving them a highlighted paragraph. Which one do you think leads to a faster, more accurate answer? In 2026, this is how we solve the trust gap. Users stop trusting Copilot when it gives them 3 sort of answers and misses the one definitely answer. The re-ranker is the tool that ensures the definitely answer is always the first thing the user sees. It acts as the final filter for truth. It bridges the gap between raw data and actionable intelligence. However, we have to be honest about the trade-offs. This level of precision is not a free lunch. When you move from a simple math-based search to a reasoning-based ranker, the economics of your system change. You are adding compute, you are adding latency. And in a cloud-hosted environment like Azure, you are adding direct costs. If you don't manage this layer correctly, the precision you gain will be erased by the infrastructure bill you receive at the end of the month. We need to understand the economics of accuracy, because in the enterprise, a perfect answer that costs $10 to generate is often less valuable than a good enough answer that costs 10 cents. The challenge of 2026 is balancing the need for 0.9 precision with the reality of a finite budget. You need the supervisor, but you also need to make sure the supervisor isn't the most expensive person in the building. But this precision comes with a cost, and if you don't manage the infrastructure, the ROI disappears. The shift toward a multi-stage retrieval architecture creates a fundamental tension between the quality of the answer and the sustainability of the budget. We've reached a point where the technical possibility of 0.9 precision is real, but the financial feasibility is often ignored. In the early days of RAG, we were focused on proving that the concept worked. We didn't care about the cost per query because the volumes were low. But as you scale from 10 users to 10,000, the math changes. The secondary layer of reasoning that makes the system trustworthy is also the layer that can make it prohibitively expensive. Because in the enterprise, accuracy is a luxury good, and if you haven't designed your infrastructure to handle the weight of that luxury, your project will consume its own ROI before it ever delivers a single dollar of measurable value. The economics of accuracy, performance versus cost. The reality of the standard tier in Azure AI search is that semantic ranking is a pay-to-play game. You cannot simply toggle a switch and expect your existing budget to hold. When you enable the @search re-ranker score functionality, you are moving away from the fixed cost world of basic search units and entering a world of variable query time billing. Let's look at the numbers. For a moderate query volume, say 50,000 searches per month on a 20 gigabyte dataset, you are looking at a monthly overhead between $300 and $800. That might sound manageable for a single department, but when you consider that this is just the search layer, and you still have to pay for the LLM tokens and the embedding generation, the total cost of ownership begins to spike. We've seen organizations launch a Copilot pilot, see massive success in user satisfaction, and then immediately pull the plug when the first full-scale invoice arrives. They were so focused on the performance that they forgot to check the price tag of that performance. This is the primary reason why RAG projects die in the transition from lab to production. The cost of being right is higher than the cost of being wrong. So how do we solve this? How do we keep the precision without bankrupting the IT department? The answer lies in semantic caching. In 2026, semantic caching is the ROI savior for the enterprise. Here's the problem we're solving. Employees tend to ask the same questions in slightly different ways. What's the holiday policy? Can you show me the rules for time off? How many days of vacation do I get? In a standard RAG pipeline, each of those questions triggers a full retrieval, a semantic re-rank, and an LLM call. You are paying for the same answer 3 times. Semantic caching stops that waste. It uses a lightweight embedding model to identify that those 3 questions share the same intent. Instead of going back to the expensive reasoning engine, the system pulls the verified answer from a high-speed cache. This can reduce your LLM calls by 60% to 80%. And the user experience transformation is even more dramatic. You go from a 3-second wait for a live GPT-4 inference to a sub-50 millis cache hit. That is a 250x speed improvement. Suddenly, the Copilot feels instant. It moves from being a slow tool that people tolerate to a responsive assistant that people actually enjoy using. But caching is only half the battle. The other half is selective enablement. One of the biggest mistakes architects make is applying semantic ranking to every single query. You don't need a deep reasoning transformer to find a document titled 2025 expense report template. A basic keyword match is more than enough for that. The strategy for 2026 is to keep the simple hits on the cheap layer. You should only trigger the L2 re-ranker on complex, natural language queries where the intent is ambiguous. By implementing a logic gate at the front of your pipeline, you can reserve your budget for the queries that actually need the extra precision. Think of it like a triage system. The cheap layer handles the 70% of routine requests. The expensive semantic layer handles the 30% that actually drive business value. This is how you balance the budget. You make sure the cost of the search doesn't exceed the value of the answer. If a query is worth 10 cents of productivity, don't spend $1 of compute to solve it. We also have to consider the tiering of the data itself. Not all documents require 0.9 precision. Your internal cafeteria menu doesn't need a Bing-derived re-ranker, but your regulatory compliance documents do. By partitioning your search indexes and applying different ranking strategies to each, you can optimize your spend based on the criticality of the information. This is what we call value-based retrieval. It's the realization that accuracy is not a binary choice. It's a sliding scale. And as an architect, your job is to move that slider based on the specific needs of the business unit. The goal isn't to build the most accurate system possible. The goal is to build the most accurate system that the business can actually afford to run. Because a perfect AI that is too expensive to use is just a very sophisticated paperweight. In 2026, the winners won't be the ones with the highest benchmarks. They will be the ones who figured out how to deliver 0.85 precision at a cost that scales linearly with their growth. They are the ones who treated the infrastructure as a constraint, not an afterthought. Managing the cost is the technical side of the equation. But even if you get the economics right, you still have a human problem. You have to address the gap between the licenses you've bought and the actual trust your users have in the system. Because if they don't trust the answer, it doesn't matter how much it costs to generate. They'll just go back to searching the old way. And that brings us to the governance gap. Because trust isn't just about technical accuracy. It's about the framework that surrounds that accuracy. It's about knowing that the AI isn't just right, but that it's allowed to be right in the first place. Managing the cost is the technical side, but the executive side is about the governance gap. Optimizing your infrastructure only solves part of the equation. You can build the most cost-efficient precision engine in the world, but if your leadership team is terrified of what it might surface, the project will never leave the sandbox. We have reached a point where the bottleneck isn't the compute budget or the latency of the re-ranker. The real friction is the gap between the licenses you've assigned and the actual authority the AI has to operate. The governance gap. Why policies are failing usage. We currently have 15 million paid seats in the ecosystem. Yet, the workplace conversion rate is stuck at a staggering 35%. This means 2 out of every 3 licensed users are essentially ignoring the tool. They stop using it after the 3rd hallucination. Trust is fragile, and poor retrieval destroys it faster than any training session can build it. Governance isn't just a document, it's a technical control. Without it, your RAG project dies at week 12. So what does the new model look like in practice? It's a move toward governed agents. The era of the chatbox is ending. We are moving away from a world where you ask a question and hope the math finds a document. The new model is about delegation. It's about moving from a system that merely retrieves to one that actually reasons about the search process itself. We are entering the age of the governed agent, a system that doesn't just look for data, but understands the rules of the house before it even starts the engine. The 2026 roadmap, from retrieval to reasoning. If you want to stay relevant in the next 24 months, your roadmap has to shift toward agentic RAG. This is the next frontier. In a standard setup, the system takes your query and runs a single search. In an agentic setup, the AI plans the search. It looks at your request and decides if it needs to hit the vector store, query a SQL database, or perhaps check a real-time API. It reasons through the steps required to find the truth. This is where GraphRag becomes the gold standard. For high-stakes environments where you need 99% accuracy, you can't rely on flat document chunks. You need a knowledge graph that maps the relationships between entities, people, projects, and policies. This allows the AI to understand that when you ask about the lead engineer's budget, it needs to find the person, then the project they lead, and then the specific financial ledger associated with that project. It's a multi-hop reasoning chain that flat vector search simply cannot perform. But here is the hard truth. Your AI is gated by your metadata, not your license count. If your SharePoint sites are a graveyard of document1 docx and final v2 really final.pdf, no amount of agentic reasoning will save you. Preparing your data foundation is the only way to avoid the competitive lag that is coming. Organizations that wait to fix their retrieval layer will find themselves stuck with a 35% adoption rate while their competitors are automating entire workflows. We are moving from vector search as a tool to semantic strategy as a core business competency. Your transformation starts with a retrieval audit. Stop measuring how fast the AI responds and start measuring how often it's actually right. Identify the top 10% of your most complex use cases, the ones where accuracy is a requirement, not a suggestion, and implement the L2 re-ranker on those pipelines today. If this shift in the model changed how you think about your architecture, follow me, Mirko Peters, on LinkedIn for more deep dives. If this helped you diagnose why your RAG project is currently failing, leave a review. It helps this podcast reach the architects who are still struggling in the top K trap. Your next step is to check out our deep dive on agentic workflows to see exactly where this precision is headed next.